Welcome back, Controls Champions. In the last video, we looked at making a couple fairly simple output rungs to extend and retract this pusher right here. We're able to run this in auto mode, getting input from the sequences, and we can also run it when we're in manual mode, not auto mode, using a manual push button. But today we're going to kick it up a notch. Bam! So, quick recap of what we did last time. We're connecting to the sequences with these two bits. We're just watching the step of the sequence that we're connected to. So, sequence 1, that's these steps as we go through the sequence. Now, that works. It's simple, it's easy to understand, but it doesn't tend to scale very well. For example, what happens when I want to run this output from many places, from 10 or 20? That does happen, I've seen that, and it's pretty atrocious on ladder logic because it just runs right off the screen. It takes a lot of scrolling to capture that whole single rung, that simple idea of, oh, these things make that thing go. And I try to stay away from that. I don't like monster rungs. It's not always avoidable. Sometimes that's just how the language works, but I try to avoid them, and we're going to talk about a good way to avoid that today. But before I get into that, what do we really want with this? What's our philosophy? What's our intent when we're designing? First of all, we want this to be readable. That means concise and labeled. Concise meaning not huge, so obviously 10 to 20 things here is not concise. And right now these aren't labeled at all. This is just a step number. Now we could put a comment on these tags, but that runs into the same trouble that we're going to run into if we ever want to change the sequence. Not only do we need to change this step number, but we also need to change the description on top of that tag. So let's say I'm looking at the sequence and I realize that I need to add a step before we're doing the pushing. Okay, well, I can copy paste this rung here. This step now, maybe it used to be 2 and now it's going to be 3 or something. So not only do I have to update that comment, but I have to come over here and update that step from 1 to 2, 2 to 3, whatever it is. So it becomes a multi-step process. So it's right now, this is not concise or labeled. Second thing we really want is maintainable. Well, what does that mean? Obviously, readable is part of that, but it also needs to be changeable, which is what I just talked through, is going back and changing that sequence or which step of the sequence is driving the output. And we want to be able to come back and follow cause and effect in the program for debug purposes. Now, this right now can do that. I can cross-reference this back to whatever sequence it came from. If we decided to make a single bit, maybe that we wanted, let's just say we had a command pusher bit. Yeah, we could make that bit, sure. Now I could latch and unlatch this from everywhere in the program, so it would be concise, it's readable, it's got a name now, but we can't track where it came from. We don't know what is calling this right now, and that is a really big deal when you're trying to debug a machine and there are 100 different places that are writing to the same tag. So we're going to talk about a way to get this readability, get this conciseness without having the issue where we can't follow it through the program. That's what I've got right here. So instead of having a command pusher extend bit, I have created a command pusher extend DINT. That's a double integer, a 32-bit integer. I made that here in the global variables table. So we got one for extend and retract. And because I can address each one of those 32 bits individually, I can trigger this command from 32 places. So what does that look like in an actual sequence? I can put an output wherever I want here. I can write to GLV because it's global, command pusher extend dot whichever bit number I want to use. this case, I'm going to use 0. If I did another one on a different rung, maybe I would do .1, and we could just keep counting up like this. So now if I come back to my output rung, if I see that this output is turning on in a machine I'm doing some debug on, I can look here and I can go to cross references, and I can see that that pops up in 2 different places. These are the places that I just added. And because it's a different bit, I can also look at this and say, oh, well, the number in command push or extend is 2 right now. Okay, that means it's bit number 1, because that's just how the binary converts to the decimal that we would see when we're looking at this value. As this expands, this list here will grow. And we can always tell if we're using the same bit in more than one place, which we should not be. We should only use it in one place, just because it'll show up more than once in here. And we can even sort the list if I had. I can show you an example. If I've got, let's just say I put number 1 here twice. We'll call it a copy paste error. This happens. Come back to my command pusher. Oh, I see 1 showed up twice. That's an issue. Let's fix that. That's another thing that helps us with debug. And here we end up with, these are functional rungs. This is a little closer to what I actually do in production on a real machine, having a not equals like this instead of a big long list of bits. I hope that's helpful. We'll see you next time. Thanks, John. The weather is beautiful here at Breen Machine. Looking at the map, we can see a massive subscriber front coming right through here, with a high chance of likes and shares. And I would bet you we'll see some comments in the near future as well. Don't miss the great weather. Click here to keep it coming. Back to you, John.